All right, we are going to look at section 3.5 today. That involved graphing rational functions. We had a lot of details that I expected you to find. There will be a blank for each of those details like you see on the board here. If something doesn't exist, for example, if there is no slant asymptote, you should say no solution or none, right? You need to put something in the blank. If you leave it empty, it tells me that you didn't know how to find that answer, not that there wasn't an answer. Does that make sense? Okay, so every blank needs to have something written in it. All right, first one, we have f of x equals 4x divided by the quantity x squared minus 36. How do we get started? What do we have to do? Factor it, yep. Nothing in the numerator to factor, but the denominator could be factored into what? Okay, x plus 6, x minus 6. Okay, now, what does that help us find? Okay, so where do we look for those vertical asymptotes? Where do we find our vertical asymptotes? We look in the denominator. Now, be careful, because if there's something in the denominator that cancels with the numerator, then it's not a vertical asymptote, it's a whole. Okay. Do we have any factors in the denominator that would cancel out? No. So we're going to have vertical asymptotes at what two values? Okay. So x equals negative 6 and x equals positive 6. Two vertical asymptotes. Okay. Do we have any holes? No. So you're going to write the word none, or you can write no solution if you want. But you need to put something in that blank. How about horizontal asymptotes? How do we figure out those? We look at the degree. So it's often easier to look before you factored it. All right, so go back to the original function. The degree in the numerator is 1. Degree in the denominator is 2. What happens when the top degree is smaller? Okay, we have one at 0. What would happen if the top degree and the bottom degree matched? We go to that ratio of leading coefficients, and when the top degree is bigger, there's no horizontal. Okay, so do we have a slant asymptote? No. You cannot have a horizontal asymptote and a slant asymptote. You'll have one or the other. Okay, so we said there's a horizontal at y equals 0, which means we'd write none for slant asymptote. All right, x and y intercepts, how do we find those? Okay, so x and y intercepts are the values we get when we plug a 0 in, one at a time. All right, so x-intercept is the value I get for x when I put a 0 in for y. And the y-intercept is the value I get for y when I put a 0 in for x. Okay, so what if we put a 0 in for y? That means this f of x is now going to be a 0. If you picture taking those x plus 6, x plus x minus 6 factors and multiplying them to the other side, they're going to get multiplied to that 0. And 0 times anything is 0. So we really just care about the numerator. What makes the numerator 0? And in this case, what do we end up with? 0. So we have a little problem here because 0, 0 is the origin, and that's going to be your x and your y-intercept, right? They both cross there. So when I put a 0 in for x, I got 0 for y. If I put a 0 in for y, I'm going to get 0 for x. It only gives me one dot on my graph. We'll have to find some other ones. Okay. Looks like I forgot to draw in the horizontal asymptote. We said we had one at 0. Can we have a point on the horizontal asymptote? Yes. Can we have any points on the vertical asymptotes? Because remember, vertical asymptotes are what makes the denominator undefined, right? We can't divide by 0. So we can never touch a vertical asymptote, but we can cross a horizontal asymptote. Typically what happens, you cross it somewhere kind of in the middle, close to the origin, and then the horizontal asymptote tells you what your graph does as you go away from the origin. Okay? All right, so the last blank that we have to fill in here is domain. What are the issues we had? What values were problems? The 6 and -6. So your vertical asymptotes or holes, whatever you get there, is tied to your domain, right? Those are the problems, the ones that make the denominator 0. So we are going to have to jump over a -6 and a +6. So we're going to start at -infinity. We'll get to -6 and jump over it. Go from -6 to +6, jump over that, and then continue on. All right, now, we don't have enough information on our graph to get a good picture. We've got a few asymptotes drawn in, and we've got 1 point. We need to find some points in each of those chunks, in each interval. Okay, so I'm going to need something to the left of this vertical asymptote at -6. So let's say we pick -7. All right, I need some things in between my two vertical asymptotes, and since they're so far apart, I do want to find a couple more points in there. So let's use -3 and +3. And then we need something to the right of +6. We can choose 7 or 8, something like that. Okay? So let's start with the -7. You can plug it in to the original function or to the factored version. It doesn't matter. If we put a -7 into our factored version, the numerator becomes what? -28. Denominator, we've got a -7 plus 6. That would be -1. We have a -7 minus 6. That would be -13. And -1 times -13 would be +13. What would 28 divided by 14 be? 2. So we're around a 2? Yes? And it's a negative? So go ahead and take your calculators. What's 28 divided by 13? 2.2 roughly? All right. Would we get anything different if we plugged in a +7? Look back at the function. In the denominator, our x is getting squared, right? So we're going to get the same answer, whether it was a 7 or -7. But what changes in the numerator? Now it's a +28. So we're going to get the same value, but a positive version of it. All right, so for +7, we get +2.2. All right, let's go ahead and try the 3 and -3. Again, you can dump it into the factored version or the original. I get a numerator of -12. Denominator, I end up with 3 times -9, so -27. Yes? No? What do we get? Positive what? What's 12/27 as a decimal? What? Okay, so positive 0.4. And then if we put in the +3, what do we get? We get 12 divided by -27. Yes? So we're going to get a -0.4. All right, go ahead and plot those points. -7, we're down a little below -2.2. At -3, we are up at 0.4. At positive 3, we are at negative 0.4. And at 7, we are at a little over 2. Okay, so can you picture what's happening? Can you tell where your graph branches should be? You've got some points. We don't have a lot of them, and you could certainly find more points if you're not positive about your graph. But we do have the asymptotes in there for a reason, because our graph should be approaching them. So I would look at a branch in there, approaching those asymptotes and going through that point. I look at this middle chunk. I know I'm above the x-axis to the left of the y-axis, and then I'm below on the right side, so I know I'm going to be coming down like this somehow. All right, and then I know that on the far right, I have another branch up in here. Okay. So if this was a test question, I would expect to see all of the details that you see on the board. You must have some points, at least 1 point plotted in each of the chunks, right, to know where that graph is. All right, looking at our next one. Can we factor the numerator? What would it factor into? All right, x plus 6x minus 1. Does anything drop out? Can we cancel anything? No. So since nothing goes away, we know we don't have any holes. All right. What makes the denominator 0? A negative 2, and that's the problem we have, right? We have a problem at negative 2. It makes our function undefined. So since it doesn't go away, it's a vertical asymptote. And I must have equations for asymptotes, not just a number, right? But x equals negative 2. And because I can't be at negative 2 for my domain, I'm going to have to skip over negative 2. All right. So we know we have a vertical asymptote at negative 2. Do we have any horizontal asymptotes? If you look at the degree, the top degree is bigger, which tells me no horizontal. Do we have a slant? A slant asymptote. If the top is exactly 1 bigger, we have a slant asymptote. All right, so how do we find it? How do we find our slant asymptote? I need an equation for it, right? It's going to be a slanted line. Y equals mx plus b. I need to find that equation. How do we find it? Flip back in your notes. We have to divide, yes. Either synthetically or with long division. Can we do this division here synthetically? Yes, that's the faster way, so we'll go ahead with that route. Our coefficients for the numerator was 1, 5, and negative 6. If we are dividing by x plus 2, what number goes in front of my synthetic process? A negative 2. All right. We bring down the first number to get us started. We multiply the negative 2 times 1, and then we add our column. We multiply the negative 2 times 3, and we add our column. What did those numbers mean? What's the negative 12? That's the remainder. Remember we talked about slant asymptotes. The remainder, this negative 12, is trying to be divided by x plus 2. And as x gets really, really large, you're taking negative 12 divided by a huge number. Okay? Think of taking negative 12 divided by 10 trillion. It's going to be almost nothing, right? So we ignore the remainder. And now we have our y equals mx plus b. What's my equation? Y equals 1x plus 3? Okay. How do I graph that? Good. Start at 3, and then a slope of 1. All right. So we've got our slanted line. All right. Let's look at intercepts. How did we find the X-intercepts? How do we find X-intercepts? Put a 0 in for. If you're finding X-intercepts, you put a 0 in for Y, right? You're trying to find the number when Y is 0. If we put a 0 in for Y, what are we looking at? Numerator, right? The x plus 2 on the bottom is going to get multiplied to 0 and still be 0. It's the top part, the numerator, that causes the X-intercepts. So what numbers give me 0 for the numerator? A -6 and positive 1. So I have 2 X-intercepts. I have one at -6, and I have one at positive 1. All right, Y-intercepts. The value for Y when X is 0. Well, if I put zeros in for all of my X's, anything with an X is going to go away. I end up with -6 divided by 2. So -3. All right. When you have a slant asymptote, we said there were 2 basic shapes. All right. One option is to have a graph inside the asymptotes. Okay. And another option is to have a graph on the outsides. All right. Based on the intercepts that we've plotted, which picture do we have? The ones on the outside. So we have a pretty good idea on the right side here. We know that we have to approach the asymptotes. All right, so we can get that branch pretty well drawn in. On the other side, let's find one more point. Let's plug in a -4. What do we get for Y if we use -4? And again, we can plug it into our factored form. Might be a little easier. All right, so if we put in a -4, denominator becomes -2. Numerator, we have 2 times -5, which gets us positive 5. So at -4, 1, 2, 3, 4, we're up at 5. All right, so can we see that branch as well? Okay, now, a couple things about your graph. It is very common, every year this happens, students fill out all the stuff that we put in the blanks on the right-hand side correctly, but their graph doesn't match it. And what I mean by that is, we said that we should have X-intercepts at -6 and positive 1. And yet some students will turn in a graph and it's not crossing at -6 and positive 1. Right? We find all this information for a reason. We want to get as accurate a graph as possible. I'm not asking you to plot 50 points to have your graph be perfect, but it should fit what you come up with. It should be approaching the asymptotes. It should be going through the X and Y intercepts. It should be going through any extra points that you have to find to figure out what the shape is. Okay? But make sure those match up. All right. I'm going to pause the recording for a second. I want you to talk at your tables. What causes a hole in the graph? All right. So what did you come up with? What causes a hole in the graph? Okay, so when there's a factor, when there's a common factor in denominator and numerator, yes? If we can cancel it out, it leads to a hole instead of a vertical asymptote. It still is a domain restriction. It's still something you'd have to jump over when you list your domain, but it wouldn't be a vertical line that you're approaching. It's just a little hole in the graph. Okay? For the next question, we're still finding all those details, but I'm not going to have you graph it. Okay? How do we factor the top? Okay? So, do we have any factors that we could cancel out? Yes. Which means this reduces to what? Just an x plus 5. Okay? So, what this is telling me is if I graphed this, my original function, and I graphed y equals x plus 5, they're going to be identical except for the hole. What does a y equals x plus 5 look like? It's just a line, right? So, my original function would be a line, but there'd be a hole in it. Okay? All right, start with horizontal asymptotes. Look at your degrees. Do we have a horizontal? No. Would we have a slant? We would. They didn't ask for one here, but we would have a slant asymptote. We could do that synthetically if we had to. Okay. Vertical asymptotes. We had one number that caused a problem in the denominator, correct? It was a 5. What happens at 5? It's a hole, right? We got rid of it. We were able to simplify down to this, where there is no denominator. So we don't have a vertical asymptote. We do have a hole. The hole happens at x equals 5. Okay? Now, x equals 5 is a line, right? Vertical line. But we don't want to make it look like it's a vertical line, because it's not a line. It should be just a hole. What we're saying is that the hole happens when x is 5. What happens in my equation if I put a 5 in for x? 5 plus 5 gives me 10. So that's the location of my hole, the point 5, 10. Okay? Now notice to find that value, I had to use the reduced version. I can't plug a 5 in here because it makes this undefined. But I can plug it into the simplified version. And that's how you find the exact spot where your hole is going to be. All right, X-Intercepts. Talk at your tables. What would you come up with for X-Intercepts, Y-Intercepts, and domain? Go ahead and answer those 3, and then we'll put the recording back on. All right, so X-Intercepts. We look at the numerator, yes? What makes the numerator 0? Now, I saw some people give me 2 answers. They're looking at this part of the numerator where we have it factored into x plus 5, x minus 5. So I looked at some papers and I saw a -5 and a +5. However, we said that at +5 we had a hole. It can't be an x-intercept and a hole at the same time. So when you find your x-intercepts, don't use the unsimplified version, use the simplified version. Okay? So putting a 0 in for y in the simplified version gives me -5. Putting a 0 in for x in the simplified version gives me a positive 5. Yes? And then domain. What's the number we had to jump over? A 5? All right, so earlier you said y equals x plus 5 is just a line. What we would have, all right, y-intercept at 5, we have a slope of 1, right? My board's off again. It's not going to let me fix it. All right, it's going through the point. We have a hole up here at 510, right? Last one that we're going to graph. Can we factor it? What could we do for the numerator? If we take a 2 out, what's left? Okay, x squared minus 16, and that factors into what? All right, denominator, how do we factor x squared plus 4x minus 5? Plus 5 minus 1? Okay. Any factors that drop out? So that tells me what over here, what blank can I fill in? No holes. Okay? Because those factors didn't drop out, we have two what? Vertical asymptotes. Good. Two vertical asymptotes. Where are they? At -5 and +1? All right. Vertical asymptote at -5 and +1. Do we have any horizontal asymptotes? Yes. It's actually easier if you look at the original unfactored version, right? What do we know about the degrees? They're the same. What happens when the degrees are the same? Yes, leading coefficients. So in this case, the leading coefficients would be 2 over 1. 2 divided by 1 is just 2. So we have the equation y equals 2. If we have a horizontal asymptote, can we have a slant? All right, so we can fill that in. X and Y intercepts. X-intercepts are what makes the top 0. Look at your factored version. What makes the numerator 0? All right, so we have 2. Okay, 2 X-intercepts. Looking at Y-intercepts. If we put a 0 in for all of our X's, that's 0, that's 0, that's 0. We have -32 divided by -5 left over. Negative divided by negative is positive. What's 32 divided by 5? All right, 6.4. Okay, last blank is domain. What are the numbers we cannot use? -5 and +1 are vertical asymptotes. So we're going to skip over -5, and we're going to skip over 1. All right, do we have enough points graphed to know what our shape should be? Not quite. We do know that we have a branch down in this section. We know we have something going on in between our vertical asymptotes, but we don't know what's happening on the far left. So let's dump in like a -6 or -7. We'll use -6. All right, if we put a -6 into our function, again, we can put it into the factored version if that's a little easier for you to compute. We end up with 2 times -10 times -2 for the numerator, and we end up with a -1 times a -7 in the denominator. So 40 divided by 7. 42 divided by 7 would be 6. So we're at 5 point something. I think it came out to be about 5.7. So at -6, we're up at 1, 2, 3, 4, 5.7. Up in there. Okay? So we know that there's a branch up in this top left section. We know that there's something going on in the middle. We're going to come back to that in just a sec. We also know that we have a branch in the bottom right section, okay, based on the dots. Now, could you plot a few more points? All right, so if this was a test and you had a little extra time, double check some more values. I am going to find one more point in that middle section. Let's go ahead and dump in a -2 and see what we get. All right, so for the numerator, we've got 2 times -6 times 2. Denominator, we end up with 3 times -3. -3. So we end up with -24 divided by -9. So positive 2.7. All right. So at -2, we're up at 2.7. So we do expect something like this based on those dots. Okay, again, you want your graph to be approaching those asymptotes. Questions on that one? All right. The last question uses the picture we just drew. It's asking us to analyze our picture and indicate where our function is headed in 6 different situations here. The first one says, as x approaches -5 with a little negative sign next to it. What does that mean? We're coming from the left, okay? That little negative sign means we are approaching from the left side. A positive sign means we're approaching from the right. So what it's asking you to do is analyze your graph as you get close to those vertical asymptotes. So as I move closer and closer to that -5 mark from the left side, my y value is pointing up towards infinity. So y is approaching positive infinity. But as I move closer and closer to that -5 from the right-hand side, my graph is pointing down. So the closer I get to -5, the closer I get to negative infinity for y. All right, let's go over here. What happens as we approach 1 from the left and right? On the left side of my vertical line at 1, my graph is pointing where? Up, so positive infinity. And on the right side of x equals 1, my graph is pointing down. Okay? So when it's asking you to approach a specific x value, like the -5 or the 1, they're talking about those vertical asymptotes. What's happening as you get close? And your answer should always be positive or negative infinity, right? That's why the asymptotes are there. The last chunk here is asking what happens as x goes far away from the origin. Now we are approaching that horizontal asymptote. So as we go towards the negative side, so I'm going this direction now, my graph is coming down and leveling off just above 2. My y values are getting closer and closer to that 2. Same thing is happening over here. All right, I'm getting closer and closer to that 2 from the underneath side. Okay. All right, so your homework. You are going to do page 437, questions 55 to 62 and 64.